Hi, Assalamualaikum. Today we will present about assigning warehouse pickers to picking zones based on the time taken to complete tasks. This is our group members. Now, I will briefly discuss a study on warehouse order picking optimization. Modern warehouse facilities play a crucial role in today's supply chain and logistics systems. One of the most critical operations within a warehouse is order picking, as it directly impacts operational costs and customer satisfaction. However, order picking efficiency varies significantly due to the differences in warehouse layout, picker experience, and the distance traveled by pickers across different zones. These variations result in unequal task completion times among pickers. This study focused on optimally assigning warehouse pickers to picking zones. Each picker must be assigned to exactly one zone, and each zone must be handled by only one picker. The primary objective is to minimize the total time taken to complete all picking tasks, thereby improving overall warehouse efficiency and productivity. To solve this problem, the warehouse picking system is modeled using graph theory. Pickers and picking zones are represented as vertices in a weighted bipartite graph, while the each weights represent the time required for a picker to work in a specific zone. An assignment optimization algorithm from the Google OR tools library is then applied to identify the combination that results in the lowest total picking time. Data for this study is obtained from the article Logistics and Supply Chain Forum written by M.S. Radhakrishnan, also known as Krish. The article provides a visual layout of warehouse picking zones like you can see on my left, which is used to analyze picker movement and operational efficiency. This approach demonstrates how graph theory and optimization tools can be effectively applied to real-world logistic problems. By optimizing picker zone assignments, warehouse can significantly reduce picking time and enhance operational performance.
Next, I will explain the assumption used in the warehouse picker assignment. The problem is the model is using bipartite graph, which consists of two groups of vertices. The first one is warehouse picker and picking zone. Each picker and each zone is represented by one vertex. Every picker is connected to every picking zone, meaning any picker can be assigned to any zone. However, in this model, one picker is assigned to only one zone and each zone is handled by one picker. The connection between pickers and zones are weights that represented the picking time in minutes, and these time values are assumed to be constant. The table shows the list of vertices used in the model. The pickers are labeled from P1 to P15, and the picking zones include A, AX, AY, AZ, B, BX, BY, BZ, C, CX, CY, CZ, S, SA, and SR. The values in this table are converted to an adjacency matrix which contains all the input data from the assignment. Each value represents the estimated picking time, where smaller values indicate faster performance in a zone.
Okay, for this part, I will explain how the assignment problem was solved using Google Colab and Google OR tools. Okay, first, the problem is formulated as an assignment optimization problem where a warehouse picker needs to be assigned to only one picking zone and each picking zone must be handled by only one picker. To represent this, we model the problem as a weighted bipartite graph with pickers on one side and picking zones on the other. One set of nodes represent the warehouse pickers, shown in blue, and the other set represents the picking zone, shown in green. Next, in Google Colab, we use Python and OR tools to define the mathematical model. We start by creating binary decision variables where a value of 1 means a picker is assigned to a particular zone and 0 otherwise. Then, we define the constraints of the model. The first constraint ensures that each picker is assigned to exactly one picking zone. The second constraint ensures that each picking zone is assigned to exactly one picker. These constraints guarantee a one-to-one assignment between pickers and zones. After that, we define the objective function, which is to minimize the total picking time based on the time matrix provided, or tools then solve this optimization problem by searching for the best feasible assignment that satisfies all constraints. Once the model is solved, the results are displayed in two ways. First, the optimal assignments are printed in text form. Second, the solution is visualized using a bipartite graph, where only the selected edges from the solution are shown. So, this is the result that we obtained by using Google Colab and OR tools. The result and its analysis will be explained in more detail in the next part of the presentation. Thank you.
On this slide, I am presenting the key result from the warehouse picker assignment optimization. Table 2 shows the optimal assignment of 15 pickers to 15 picking zone based on the solution obtained. Each picker is assigned to exactly one unique zone and each zone is handled by only one picker. So, the one-to-one assignment constraint is satisfied. The main outcome is that all assigned picking times are 9 minutes. This indicates the assignment is well balanced because no picker is given a longer picking time than the others. When we total all the assigned times, the minimum total picking times achieved is 136 minutes. Overall, these results confirm that the optimization model successfully minimized the total picking time while ensuring an efficient and fair distribution of work among all pickers. For the next slide, I will summarize the conclusion of this study. First, the warehouse picker assignment problem was modeled as a weighted bipartite graph where pickers and picking zone form two separate vertex sets, and the picking time is used as the edge weight. This graph representation provides a clear way to describe the one-to-one assignment requirement in the warehouse operations. Next, the optimal one-to-one assignment was obtained using Google or R tools to minimize the total picking time. Based on the optimal solution, the model achieved a minimum total picking time of 136 minutes. In addition, the assignments were well balanced because all assigned picking time were 9 minutes, meaning no picker was overloaded compared to others. Overall, these findings shows that graph-based optimization approach is effective for supporting better warehouse decision-making and improving operational efficiency. Finally, this method can be extended in future work by adding practical constraints such as travel distance, picker capacity, and shift scheduling to reflect more realistic warehouse conditions. Alright, that's all from us. Thank you for watching.